So looking up here, okay, so if I say event X is heads, event Y is tails, then I have probability heads, which is 1/2, plus probability tails, which is 1/2, minus the probability of both heads and tails, which is 0. So that ends up being 1. So if you have event X or event Y, and those events are mutually exclusive, then all you do is you just add up the probability. And don't subtract anything. Now, if events are mutually exclusive, are they independent? The answer is no. In fact, so if, let's say, well, for one thing, just look at this. P of x greater than 0, P of y greater than 0. If they're independent, this joint probability is Px times Py, which must be greater than 0, which conflicts with this. What a mutually exclusive event does is it tells you something. So, for instance, in my heads-tails example, probability heads, probability tails, probability heads and tails. If I flip and I have a head, then I know for sure that that's not a tail. But if they're independent events, if I flip and I have a head, that doesn't tell me anything at all about whether I have a tail or not, so I can still have a tail. Okay, so hopefully this is all coming back. One more thing, conditional probability. If I have a joint PMF, Pxy, and I divide by, let's say, Py, then what I get is the conditional probability of x given y. The interpretation of that is the following. So if I have P of x given y, then what I'm doing is I'm looking through my list of all the possible events that happened for when this particular value of y came up. And for all of those, I'm looking at the probability of x. So this is basically how certain values of y affect the probability of x. It's also sort of true over here. P of xy tells you roughly how often these pairs of x and y come up. P of y just tells you how often that particular value of y comes up. So this is out of so this is you take all of the occurrences of x and y and divide them by the number of times that just that value of y come up, and you get the number of times that x came up, given that y came up. If two events are independent, so if x and y are independent, then P of x given y is equal to what?
Px.
It's Pxy. Why is that true? Yes?
Because y's probability doesn't affect x.
That's correct, but mathematically, why is it true? Look at this.
That's y.
So what's the numerator? If they're independent, how does this work?
It's Pxy. Px.
It's Px, Py, if they're independent, and we divide out the Py, so therefore this is Px. Okay, an important concept in all random variables that's easy to describe for discrete random variables